Today we'll solve chapter 6, section 3 review. Question 1. Choose the correct answer. The notation for sodium chloride NaCl stands for 1. Formula unit, molecule, crystal, and atom. You know that NaCl is ionic compound. So ionic compound, no molecules. So NaCl represents what? Formula unit. The simplest ratio between the atoms involved in the crystal. In a crystal of an ionic compound, each cation is surrounded by a number of cations surrounded by a number of cations are the positive ions. Cations are positive ions. So surrounded with negative ions. Compared with the neutral atoms involved in the formation of ionic compounds, the crystallets that results is higher in potential energy, lower in potential energy, equal in potential energy, or unstable. When two atoms form a bond, so the potential energy decreases, so it will be lower in potential energy. Number 4, the lattice energy of compound A is greater in magnitude than that of compound B. What can be concluded from this fact? Here compound A and compound B. And the lattice energy in compound A larger than the lattice energy in compound B. So compound A is not an ionic compound. It will be more difficult to break the bonds in compound A than the bonds in B. Compound B has larger crystals than compound A, or compound A has larger crystals than compound B. So it's not related to the larger crystal. So the correct answer is choice B. It will be more difficult to break bonds in compound A than those in compound B. 5. The forces of attraction between molecules in a molecular compound are generally stronger than the attractive force among formula units in ionic bonding, while weaker the attraction force among formula units in ionic bonding, while approximately equal to 0. In the ionic compounds, they are solids, so the forces are stronger. So in molecular compounds, weaker than the attractive force in formula unit of ionic. Number 6. An ionic compound is not represented by a molecular formula because an ionic compound do not contain bonds, can form crystalline solids, has no net charge, while lacks molecules. Why? We don't have molecular formula in ionic compounds because they don't have molecules. They lack molecules. Compared with the energies of neutral atoms that form the ions, a crystal lattice has 0 potential energy, higher potential energy, lower potential energy, or equal potential energy, and we mentioned it before, when they bond they form lower potential energy. Number 8, the salts NaCl solid and CaCl2 solid are good conductors of electricity, positively charged, held together by ionic bonds both A and B. NaCl in the solid form, pay attention, in the solid form. They are good conductors? No. Ionic compounds in the solid form are not good conductors. They are positively charged? No, they are neutral. So they are held together by ionic bonds. Compared with a solid ionic compounds, solid molecular compounds generally have lower melting points, or are more brittle, or are harder, or conduct electricity as liquids. Compared with solid ionic compounds. Solid molecular compounds, with respect to ionic compounds, they have weaker forces, so they have lower melting points. Because strong attractive forces hold the layers in an ionic crystal in relatively fixed position, ionic compounds are hard, are brittle, are not electrical conductors as solids, all of the above. Strong attractive forces hold the layers in an ionic crystal in a relatively fixed position. Ionic compounds are harder, yes. Brittle, yes. Are not electrical conductor as solid, yes. So all the above. In a crystal of solid chloride, sodium chloride, how many oppositely charged ions does each Na positive and Cl negative ion have clustered around it? 1, 2, 4, or 6. If you draw the crystal structure of NaCl, you will find that each atom or each ion, positive ion, is surrounded with 6 around it. For example, this one surrounded from up, down, left, right, forward, backward, with 6 negative and also the opposite ion. The arrangement of ions within the crystal structure and the strength of the attraction between them vary with the size of the ions, charge of the ions, number of ions of different charge, or all of them. The arrangement of ions within a crystal structure and the strength of the attraction between them vary with size of ions, yes. Charge, yes. Number of ions of different charge, all of them. The energy released when 1 mole of an ionic crystalline solid is formed from ions in the gas state is known as the energy released 1 mole of an ionic crystal solid is formed from ions in the gas form. It's called Lutz energy. Some ionic compounds do not dissolve in water because the attraction force between water molecules and the ions are not as strong as the attraction between the ions. They are less dense than water and float on the surface. Water is a covalent compound, and covalent compounds cannot dissolve ionic compounds. Water molecules cannot fit in the space between the ions in the crystal lattice. So the choice is A. Number 15, a charged group of covalent bonded atoms is known as anion, polyatomic, formula unit, or cation. A charged group of covalent bonded atoms is polyatomic. Like, for example, SO4, -2, CO3, -2 also, NH4, +1, and so on. These are called polyatomic.